I elaborate. Wait, 2 years?
Well,
All right, everybody, we're going to go ahead and get started. We're running a few minutes late, so I'm going to speed it up here just a bit. Appreciate your patience while we work through some of the technical difficulties. For those who don't know me, my name is Robert Ray. My call sign is KD0YMC. I am a general class ham, and I joined this hobby probably about 2.5 years ago. And so I've, like many of you all, jumped in with both feet. I am a non-technical ham in that my background is in marketing. So I have no technical chops whatsoever. So here I am presenting to you a technical topic. So bear with me if there's any sort of hardcore technical questions, but I'm self-taught in this. A lot of people are. This is a pretty interesting topic if you are a ham radio operator who likes to tinker. Arduino is a capability that has kind of exploded in the last few years in terms of use in ham radio, and just in as well as application in a lot of other places. If you're not familiar with the site Instructables, I was just on there last night. They have something like 1,300 projects just on Arduino, and it runs a gamut from robotics to wearable technology. So this will get into a little bit of a basic overview of what Arduino is and how you can use it in general, and also how you can use it in ham radio as well. There's lots of applications. So with that, I will jump into it. I should have pointed this to the right thing. So the stuff we'll cover today are some of the basics. That, as with most technology, it has its own terminology. So we'll talk through that. We'll talk a little bit about hardware, and I'll pass around a few of these as we get into some of the topics. And we will talk about some of the amateur radio applications and a little bit around getting started. And then finally some resources for you all to be able to access as part of your learning process. So what is it? It's basically a simple microprocessor. It's not a computer. It basically does a repetitive task over and over again. And the purpose of it is really, for this, is what it is here. I spelled it out phonetically because I kept calling it the wrong thing. So I wanted to make sure that it had the right pronunciation, Arduino. It was born in Italy out of a hacker community there. A number of university folks built these things as kind of a test bed to kind of create this as part of an opportunity for people to learn low cost of entry, that kind of thing, to help people get into electronics in general. It wasn't specific to ham radio. It can be used for a variety of things. We'll get into some of the ham specific things, but you'll see this a lot in robotics, basic electronics where people use it to drive LCD screens and things of that nature. In the last couple of years, since I've been involved in the hobby, it's exploded in terms of a use of ham radio. And like I said, I'll show you some of those things. You may wonder what I'm wearing here. This is a little name badge thing that I knocked together based on using a ham radio. Using the Arduino Nano, a little OLED screen, and a couple of jumper wires and a breadboard. It took me probably an hour and a half to build it. Probably an hour of that was messing around with the code to get it to say my name and all that. So something very simple to do. And I did that mainly as a means of sort of teaching myself. And so it really is, again, non-technical background, I have no programming background. So you can get through this pretty easily. So fairly low barrier to entry in terms of learning the topic. So these boards, and like I said, I'll pass around a couple. This is all open source. I'll talk a little bit more about what that means. But these can be assembled by hand, so you can go out on the internet and find the plans for these boards, build them on a breadboard, or you can go out and buy these different devices. The price point on these things has dropped dramatically, and we'll talk a little bit about that in the future. It does have its own programming language, but if you've had any experience in programming, It's pretty intuitive, and since it's a pretty simple processor, it's a fairly easy one to figure out how to program the thing. So this is what it is. I have a few of them up here. I'll pass around a couple. That's one there. Start one over here. You can just pass them around and get an idea of what they look like. This is that's a little one there. So essentially what these things are just, it's a development board that essentially allows you to map the power and hold a little program to do a task. Up on the top are all the digital pins, so this could be both input and output. And on the bottom are analog and power pins. It does have a USB jack. Typically we'll have some sort of power input as well. You've got a couple of small LEDs that show you activity, mainly on upload and processing. And then on the right-hand side here, you have and this is not universal. Like you see, all of them are a little bit different. Some of them will have a reset button, some of them will have a programming header, but they will all have somewhat the same footprint. So there's consistency across all of those things. So you see sort of the regular size one is the one you'll see most. That's the Arduino Uno, probably one of the most popular ones. It looks like this board. There's another smaller one that is being passed around, and that's a Nano. Then there's also a couple of other smaller ones that I'll show you here in a moment. So why use this thing? Well, first off, it's inexpensive. It can be purchased for less than $30. That's the most expensive one. I'm sure that when you get into some of those other technologies, but the basic boards run $30 and less. I got a starter kit that I'll pass around here in a moment that I got for $20 at Micro Center, which includes the largest development board, plus a bunch of other sensors and resistors and that sort of thing. The small ones can be purchased for about $10 or less, depending on where you buy them. There are, like with most technologies, there are some bad clones out there, so you do have to be careful. But for the most part, if you're ordering off of eBay or Amazon or some of the larger sites like SparkFun, you'll be okay. It is cross-platform, so you can use this, regardless of what you have, you can use this technology. So both the software environment as well as the drivers and all that sort of thing are all compatible with both with Linux, Mac, and Windows. I've run them on both Windows and Macs successfully, and have found that it's pretty simple to do. In fact, you can port the programs from one to another. I do it based on how cold it is in my garage and where my Windows machine is versus my Mac. But it's really a fairly simple process. So we'll get into some of the types of Arduinos here. So these are the different types of boards that you mentioned. The Uno, this one on the lower left has an Ethernet shield to it. The one in the middle is called a Mini Pro, and it actually is more the size of the small one. It looks bigger than it is. This one in the lower right is the biggest board, so it's not two size necessarily. The one up on the top is an interesting one. Is that this is what they call a wearable. So this can be combined into a costume, any sort of dress or anything like that. So there's examples of where people have integrated these things into clothing to perform certain functions at like a Comic-Con kind of thing or a conference or something like that. But that's an interesting thing and there's a number of those kinds of things that have special application in the Arduino space. Here's a couple of other boards. Some of these have specific uses. This can be, this one on the upper left can be like a game controller type. So it's got, you can see some of the keypad, the joystick on the left. This is just a larger development board that's focused on more communications type stuff. So there's right now, I think there's 15 current types of Arduino boards that are in production. There are, most of these, it is open source, so you can find them from a lot of different companies. And you'll see here, so here's a couple other compatible boards. The Diavolino on the left-hand side. This is one that you can find at the Micro Center. And the one on the right, I forgot which one that was. It's just another open source board that was produced. And so you see some of these are buildable, so you can actually buy kits to build these things. Or, like I said, with a breadboard, you can go out and get all the parts and build one yourself. And that's why some people will build them into their end product as is, or they'll build them based on that footprint. And we'll talk a little bit about building some of these things. I'll pause there for any questions. Anybody have any questions so far? We can wait till the end if you want to, but go ahead.
What's the difference between the Nano, which I think was one that's in capacity, and the Uno?
It's mainly the footprint. The Nano is intended to can be incorporated into a product, whereas the Uno it's more of like the base pattern. If you're familiar with the Raspberry Pi, it has a bunch of shields that you can stack on top, and that can become your product. Whereas this little guy here, and I'll show you an example here in a moment, but this can be built into other products. And so that's what's running on this board right here. And I'll show you, I'll pass this around when we get to it, but it's also built into this board here. This is a slightly different version. This is the micro, but it's the same kind of thing where it's built to be left in place as a final product.
So it's less peripherals, that's more footprint basically?
Correct. Same pin out and that kind of thing, so you can basically, whatever you design on a Uno, you can use on this. So that's what a lot of people do, they'll use an Uno and scale it down once they get everything sort of set up, and then scale it down into a product. And then so you can either build a board off of it or incorporate something like that. So I know for some of you hardcore technical guys, I had to throw a spec sheet up there for one of these. It gives you an idea of the power. These are all sort of different, slightly different power. They can all operate sort of on the same basis, but they tend to be based on the 80 mega chip, 328. Typically operating voltage you're dealing with for any of the components is about 5 volts. You see on the inputs and outputs there. Some of the other boards will have larger numbers of pins, but for the most part, that's a fairly standard footprint for those. You can see the sort of the rest. The memory, it doesn't have a ton of memory on it. It does have a bootloader on there. Bootloader is essentially the thing that starts it up. So that occupies a little bit of the space. So I mentioned open source, so we'll talk through some of what that means. But there are essentially three components to the Arduino, as well as a community element too. So there's a hardware piece, that's this stuff here. The bootloader, which is the software that's already on the machine, and then the open source development kit. And that's essentially the tool, as well as the mechanism for how you get software onto the device. So terminology, and some of this is important for the rest of the presentation, but the I/O board, that's essentially the main controller. The bootloader, typically, if you're getting started in this, you don't have to mess with the bootloader. It's already on the machine. It gets loaded on when you first start up, so you shouldn't have to do that. But if you want to change it, there are programs within the development environment that allow you to do that. I've never messed with it. It seems too hard, but and you'll find there's a lot of resources out there that help with that. The shield, and those are essentially the add-ons. Like this is I'll pass this around, but this is a very simple development shield. It comes with a little breadboard as well as an additional space to put components and things like that on there. These are all fairly inexpensive. I think that was like $3, something like that. So it really gives you some flexibility around design. The sketch, that's essentially the program, and we'll see what that looks like here in a little bit. But that's if you're building a project that is basically you're copying an instruction or something that's someone's already done, and you're basically replicating that. A lot of times the sketches are on the internet, and you just download them, plug them into the environment, plug them on the machine, and you're good to go. The IDE, Integrated Development Environment, I'll show you a little bit here in the future, but that's essentially the development environment. It has both your, if you're familiar with Chirp, operates a little bit like that, but it has an ability to load a program on there instead of a file around repeaters and that sort of thing. the libraries, this is an important concept, is libraries are a part of the overall programming environment. But libraries, I call them helper code that helps the Arduino do its thing. And so in many cases, these will be pre-written, reusable software instructions that the program just calls out. And you'll find them, again, on the internet. There's some libraries and things like that you can pull these down from. But a good example is when you drive an LCD screen, there's a program, a library called Crystal LCD. And so you just call to that, it brings it in, helps drive the Arduino. The breadboard, so this is, if you're not familiar with a breadboard, there's a small one going around here, but this is what a breadboard looks like. I'll pass that around. It's a fairly simple thing in that it's got all these pins are available for you to put components. The top rail and bottom rail on this one are your power rails. So you would have power going into here, and then you just build your components onto this board. And once you have it set and tested, you can then copy it into a PCB board if you want, or something like that. So again, a lot of times if you buy a starter kit, it will include a breadboard in it. Sensors and modules are really just additional things you add to it to give it capability, and I'll show you a couple of those things here in a second. Kind of covered this already. So here are some of the shields, and these are things that are available by and incorporated in your projects. So you've got touch screens, data logging, wave shield. I actually have no idea what that is. I did borrow this presentation for someone with their permission, so there's some things in here that he had. But there's some other things in here that make sense. The XP shield is a home automation thing, Ethernet shield, Wi-Fi shield. Some of these things will come with some of these components on the board already. It really depends on what you end up buying. And then modules, and there is a staggering array of modules. I think on one page alone I saw upwards of 100 different modules and sensors that you could put into one of your projects. Everything from GPS modules and temperature to fingerprint to gas sensor. You can even build your own Geiger counter if you want to, if you have so inclined. And then these are some of the other sensors that you can put in there. Some of the thermistors and heat sensors and things of that nature. So there's a lot of, it's really up to you in terms of what you do with this thing. There really isn't any limitations other than, probably your capabilities around the programming part. But there's a lot of information out there in terms of what the projects out there. Like I said, there's literally thousands of projects. So building a project, and I'll go through this fairly quickly. So you can either build an existing one or build your own. So this is an open environment. You can start from scratch and program this and build it as you see fit. Most people getting started will usually build a project. And it's great to start with these things too, like there's some very basic programs just to make sure the thing's working. Like it'll blink an LED or it'll run a little bit of code for an LCD or something like that. It's very, you get training wheels. You kind of go through that process of building up your knowledge base, and then when you want to dive into bigger things, that's available to you as well. But it's a great way of getting started is running some of the basic programs that they have on the Arduino site, or Arduino.org site, that you'll see in here in a minute. So essentially you collect all the necessary components. A lot of times with these projects you'll get a bill of materials, so you can go to Mouser or DigiKey or some place like that buy these things. Hopefully you might even have a project box where you can have a lot of the stuff in there. Basically assembled based on the instructions and tutorials. A lot of times these things will come with a schematic or pictures that you basically just follow along. You then need to configure the IDE to talk to the Arduino. Again, if you've ever programmed a radio through your computer, a lot of the same process is making sure the program talks to the board. There's some other configuration stuff, but if you've tried to program through Chirp, which is the best analog, you have to go through and make sure it's the board settings right, the serial ports right, and all that sort of thing. Very doable though. Copy the sketch, upload to the Arduino, and then it'll basically reboot and run. Like this one's been running, it will run forever until I tell it to stop or turn it off. But you can also program it to run a set of, 10 times, 1,000 times, 1,000,000 times, whatever. All means to be able to run the program. So it's kind of a dumb machine. You turn it on, it does its thing until you tell it to stop. Like I said, you don't need to know programming, but it certainly helps. So here's a couple of things that you would get started with. So there's the actual Arduino on the left-hand side on the breadboard. A schematic, normally you'll find, comes with the project. They usually will be pictures. This graphic down here is a technology that I'll talk about here in a few minutes. And then you basically just start building the thing. So this is the integrated development environment, and basically this is your command console for how you talk to the board and load the programs. So the top part you'll see it's just a button bar, common icons there, upload, download, play kind of thing. The input edit area, that's where you copy the program to, and so and it's a common language program, so you'll see. The stuff will make sense when you read it. You kind of can get an idea. It'll say something like, so that sort of about 3/4 of the way down that screen, it says digital write 13 high. It basically is saying to write to the 13th pin to set the LED on. So it's kind of intuitive when you look at it. So it shouldn't be too bad to program. But there is a learning curve to it. Like the delays and things like that, those are pauses that you can program in. So that's where you can go in and tweak some of the code to your liking without necessarily knowing all the details around the programming. The bottom part is really its status in terms of talking with with Arduino and how it's loading the program. And I'll talk a little bit more about some of that.
Looks like there's a closing brace missing. It's probably rolled down.
Yeah, it's just copy the picture. But this is the Blink program that's like the first one they want you to train on. It's most basic. It basically gives you the code to blink an LED, and so it's a great way of getting started. Because then you start messing around with some of the other settings. You can get a long blink, short blink. You can shorten the delays between the blinks. So it just gives you an idea of getting a feel for the thing. It's his program, so when you go to compile it, it'll tell you whether you have errors or not. And so in this particular case, it says it's done compiling, which means it did find an error. If it did have an error, it would show you at the bottom. And it would tell you that it's missing a bracket or something along those lines. And it's the nice thing about it too, and you can see in the lower part of that screen where that little bracket is highlighted, it does show you, if you put a bracket in there, it shows you where the closing bracket is. If you put an open bracket, it shows you where the closing bracket is, so you know where to place it in your programming. So it's like I said, pretty intuitive. I figured it out. So if I figured it out, you got to figure it out. So this is the part I was talking about in terms of selecting the serial port and board. So this is, like I said, just like Chirp, you have to go and find the serial port that it talks to, and then it has a preset list of all the boards. And this is a critical part, is there are, just like if you're programming a Baofeng UV5 versus a BH8, I think those numbers are right. While they're both handheld radios, they do not behave the same way, and so you can't necessarily just upload the program the same way. So you have to make sure it does the handshake, so that's the important part there. So this is the process it follows when you're loading the program. You basically load the sketch. You also put any calls to the library. Those are usually at the top of the program. Compiling it just tests the correctness of the code. Upload moves it to the Arduino memory, and then the LEDs will indicate that it's loading, and then it automatically runs. And like I said, it'll run until it stops. And so this is the basic flow of how you would load it onto a Arduino. So creating your own, there's a couple of tools out there that you can do this with if you wanted to start from scratch, starting with one of these boards. There's a tool set out there called Fritzing Prints. It's a open source development, environment designed by some guys out of Germany, intended to get people involved in the design element of programming. So it's a program, it's all open source. I think it's all, you can load it on any machine. But it allows you to either develop in a PCB view, this visual view, or a schematic view. And then you can basically do all that design, and then once you've tested it, you can actually export it to files to actually create your own PCB. And I've messed around with it. I actually have something I'm working on right now for a, doesn't relate to Arduino, but it relates to building an interface box for a headset to my radio. And so very simple kinds of tool sets that you can use here, again, all free. But it has a lot of capabilities around developing Arduino type products. So it's a great environment. And so that's why you'll see a lot of these things will have the same look and feel. And that's an output of that particular product. So amateur radio applications, there are a ton. So this is one that I found kind of interesting, is that this was are you familiar with Kickstarter? People know what Kickstarter is? It's basically a crowdsourcing site where you can put an idea up there, get funding for it, and hopefully get it into production. This one actually was a successful Kickstarter program, and essentially it's a VHFUHF voice and visual product that you put on top of one of these Arduino shields or Arduino products. Load the program, and you've got a radio, and that's what he's got on that computer. He's doing digital modes. He's got that hanging off the back of his laptop. Right now, this is not advertising for the site, but I think they're selling them for about $50, so down from 100. But this is again, this is just open source. Someone decided to build this thing, and now they're selling it as a product. APRS. So there's actually a fair number of products in the APRS space. Automated position reporting system. So some of these you can build, some of these you can buy. So the one on the right is that you can buy. The one on the left, you can get all those items open source. But this is a very popular application for this. Some of the other applications, and I just threw together a bunch that were ham radio related. So upper left is someone building an Arduino VFO, and this is uses a touchscreen, and it's for the BitX40, which is a very low end, nicely built but low price point HF radio on 20 meters. I'm sorry, 40 meters. And so someone there, it's kind of a HF hackable solution. People are building a lot of tools on top of the BitX using Arduino technology. So you'll see that there's a ton of VFOs and things like that. Lower left is a weather station. Again, a very simple build. The antenna analyzer up on the upper right, I'll pass this around. This is one that I built. Greg?
Yep.
Greg, W0TLM. He's built one as well. It's about $12 for the board. You got to buy the parts from Mouser, but it's it's something you can do in an afternoon. But it's all in. You're probably $40 for a full antenna analyzer. It also has a program that runs on the PC as well. Oscillator on the lower right there, and you can see some of these are closer to finished products than some of these are sort of prototypes and that kind of thing, but it gives you an idea of what you can do with these. A fair amount of these for Morse code related. So you can build your own keyboard, keyer, decoder, or just a standalone keyer. And again, I looked for the keyer and decoder alone, there's probably 30 or 40 different projects. So everyone's done sort of their own flavor of this thing. But you can go out and find them readily. I'll talk quickly about this guy in Italy. His name's Claudio, and he's got a website that sort of focuses on hacking different products. So he does Raspberry Pis, but he's done a fair amount in Arduino space. And these are all free things that he built. So he's got a multi-band, multi-mode beacon, a CW practice emulator there, and then the APRS tracker. So, and these are all things that he built, designed, built, and all that, and shares them out there for the public. You can see, if you look closely, you can see some of the schematics on the back side that, And he's a big proponent of, once you design something, push it out into the public space, and then you can order boards and that kind of thing. But there are literally hundreds of people like this guy. And I'll talk about one of the most recognized guys that's working on this stuff. So getting started, I'll pass around this little kit. So I bought this from Micro Center. This includes feel free to open that up. That includes the mega board, as well as a bunch of different components. Everything you would need to get started, and it was $20. So if you want to, it includes a breadboard, includes the main board, and some instructions and some sensors, and so it gives you everything you would want to get started to play around in this space. So very low cost to entry. If you have a computer, you're good to go. These are some different types, but if you go, my one caution would be don't overpay for this stuff. There's some kits out there that are way expensive for what you get. Shop around, because there's really not a lot of difference between, what you get in the kit. It's all kind of the same basic components, but there's some crazy expensive ones out there. But most of these kits you can probably get for $30. That one's a fairly basic starter kit, but you can get a lot with a lot more sensors and that kind of thing. So I wanted to talk about this guy, Glenn Popeil, KW5GP. He's ARRL's guy for Arduino. He's produced 2 books on Arduino for hand, and strangely than us, they're named Arduino for hand and Arduino for hand. Not very creative, but they tell you what you're getting. So these are all projects that you can find in this book. And so it's essentially a cookbook that you can go and find these things, get the parts, follow the instructions, and you can build any one of those products. It's a kind of a staggering array of stuff, so it doesn't really matter what end of the hobby you're in, there's something in there for you. So there's some very specialized ones like a Yaesu rotator controller. There's some other basic ones like the CW beacon, a weather station, and those kinds of things. So you can really kind of pick based on what your skill level is and what you think you need for your hobby. So I've worked on 3 or 4 different projects myself with the Arduino products. Like I said, I have a VID X40 that is run by the VFO is run by a Arduino clone. So there's a lot of different capabilities out there and products out there that you can build. Resources, I'm not going to go through these, but there is a lot out there in terms of resources. A couple that I would mention is the main site, the Arduino.cc site. That's the home of Arduino. So it's a great place for just getting started. It's got a lot of instructions. There's some great programs that explain all the basics of what an Arduino is. There's a lot of tutorials, as well as exercises you can work through to actually build stuff. There's some other ones in there, but if you look at the hacking sites, Hackaday, Lifehacker, there's a bunch of sites that have that. There's a Twitter site for Arduino that's got new products and that kind of thing coming out. And then one of my favorites is well, there's a couple, but Instructables is probably one of the best sites to go. It can be it's an open forum, so some of the Instructables are good, some of them are maybe lack a little bit of detail. But it's a great place to get some ideas. And these are all links, so you should be able to, once you get the presentation, should be able to link all those. Some other product sites, SparkFun is one that has both Instructables as well as products. Make has another site that has Instructables and products. So there's a lot of resources out there to use. GitHub, how many folks are familiar with GitHub? We got a few. So GitHub is essentially it's kind of an open source configuration site for software. So it becomes a public repository for some of the software of these things. So the software of record, if you will. And so a lot of these developers will use GitHub to place their software up, and then if someone wants to update it, they can then upload a new version, but it maintains some configuration control. So you'll see GitHub in a lot of these exercises and projects as your place to go and grab the software. I think that's it for that. It's a constantly evolving, site, and I had a problem with my computer, so I'm using my backup here. Just in the last 2 days, there were like 2 other, it's constantly coming out with new stuff. If you get the ARL Magazine, QST, one of their articles is around building a VFO for a tube radio. And so there's a project where, and this is the most recent month's edition, and I saw just in one of my feeds that someone built a voltage meter out of an old Nokia display screen. So it's limitless as to what you can do with this related to the hobby. So I'll stop there. I think we have time for questions. I forgot what the format was in terms of that, but.
Yeah.
Okay.
A few questions.
My
question would be, did you look at Raspberry Pi? I mean, how did you choose to go this way versus this way?
Well, I didn't choose. I have both. But it really depends on application. This is a great application for just sort of, Raspberry Pi is more of a computer. This is a microprocessor. So it's a little overkill for some of the application of this. Because if it's just running a routine program, you really don't need the horsepower for that. The Raspberry Pi I have actually just successfully created a Whisper beacon on my Raspberry Pi this past week, and I got it broadcasting. So it's got a little bit different application. I also use it for home stereo stuff. So
it has more memory and more capability.
it behaves more like a computer. And so you can plug it in and have a display screen and have it drive all kinds of stuff. Chip, you were going to say something?
Yeah, the Raspberry Pi is a standalone, full-featured computer with a full operating system. Arduino is very much a dedicated microcontroller to a particular application.
And so it just runs over and over again. But there are stripped-down versions of Raspberry Pi that you can, there's a Raspberry Zero that can be more sort of deployable, if you will. Other questions?
Robert, I just want to point out there's a lot of information on those charts up there. All of these charts will be posted on the W0TLM.com website under Tech Field Day menu. So if you didn't get notes on all of Robert's websites up there, it's okay.
And we'll also be on the Facebook page as well as all the videos. Any other questions, comments? Go ahead.
I was just curious, as we're passing these around, are these static sensitive the way they are assembled on the board, or are they pretty much safe?
They can be static sensitive. I think they're fairly stable. I've never had any problems. I cart them around in static sensitive bags, but I think for the most part, I haven't had any problems with them.
It's kind of brave to pass that around.
That's actually one of the reasons to put it on the board. They actually do put resistance to ground on each of the leads to give it some static protection.
Well, I figured people aren't going to be shuffling their feet and zapping my board, so. Anyway, thanks everybody, appreciate it. Who do we have up next? Chip's up next.
Yeah.
So I think we have a little break before we get started. I think Chip starts at the bottom of the hour. Thanks everybody.
Sorry we had a little bit of delay getting started this morning. We had a technical problem. We're going to take a short break. There's coffee and continental breakfast items in the fire rehab food truck out there. So get some refreshments if you'd like them. And we will start at 9:30 with a presentation by Chip Fleming on radio program culture.
Oh, yeah.
I do. I've got, I haven't.
That's what I got. Yes. Came with, these are good, right? Should get a person for that. It's just a spreadsheet.
So we'll figure out how to check which.
More.
Thanks, sure. Actually, I forgot. I actually. So future club. once I test it. But it's a nice board. It's HF, so, yeah, it's not. But yeah, it's, yeah, and it's, I can't remember, there's a software. I think it's fixable. It's a known problem, so I just have to sort through.
So which one was the greatest?
I would say there are
Okay, yeah, it's a little bit involved.
Raspberry Pis are different, has gone to a different direction. And they have a lot of tools, a lot of capability around home automation.
Which is an interesting one.
Yeah. I'm building a.
So, what's your name?
Smith.
I got a little basically just mount in serial relays and have it connected to the internet.
What I'd like to have is something simple.
There's that too.
So I can check.
Yeah,
there's commercial
lot of programs.
Yeah. Well, you can make it worse or something.
Yeah, there's actually one where I've invested in one thing. It'll sense what these.
I mean, right now.
Everyone did mine. I got college credit for it actually, but I have to go through the
That's actually fairly
textbook
simple.
again. And
Yeah,
Boolean
Yeah,
algebra.
some of those maybe, there's,
I don't know if you
there's maybe more. That could honestly,
You can also start.
Boolean algebra. I have to learn that again. Yeah, I've kind of forgotten that. I mean, I have an idea how to do it, and I know there's a lot of tricks to it. It's just to figure out where your ones and zeros
I
are.
use lightning.
You have to replace
Never.
your input, output.
Well, I'm not gonna, I got. They have like oh, his program.
And eventually.
Years ago, I disconnected the coax, laid it in the Windows. Because it does all the coax.
I'd have to look into it, but I don't really have a lot of radios to really. Yeah. One day, yeah. Well, definitely, yeah.
So now I use lightning arresters and leave everything hooked up.
I'm gonna think about doing it.
The lightning arrester is expensive, no problem. All of them is work $65 a pop. I've got some of those, but they're not with it.
There's a different software
Well, yeah, but I mean, it just gets,
Oh, I know, it's just to change.
well, and then nothing.
So you working on a project or you just a general interest?
Nothing was so I've mapped out that line, more or less protected. But I've switched over to that.
Well, you may be interested in some of these weekend projects.
Yeah.
The whisper thing. I have
Shield blood.
that I bought from and I knocked together.
Sure, you find the process, like all that does is sort of shorts this.
That one, no, I definitely found it. There's a,
It's probably out on
There's no protection.
I gotta figure it out.
When I'm on it, so I get lots of strikes all around.
It's,
But you did that with Raspberry.
It's like
some of these other beacons, they're not whisper, but they're other beacons. It shows tools you can do on this. The Raspberry Pi is not a.
haven't seen
it's
these
not-
big
It's expensive. It's a little bit of a different mindset around how you operate it.
And it's coming so fast.
This goes for light now. It's almost really because it's I just hung a
Kid there, you wonder how you're going to switch that because if you're just switching from this pole, it's
I just roughly strung out to a dipole. I was just doing testing, and I reached places in Canada. So it's not going here. So it's a Tucson. Right. Oh yeah. So if you look at taper,